In episode 110, titled DLP Controls, Preventing Leakage Without Stopping Business, we frame data loss prevention as balancing protection with real workflows, because the exam expects you to understand that data security fails when controls make normal work impossible. Data loss prevention, often shortened to DLP after first mention, is not just a blocker. It is a policy engine that observes how sensitive data moves and then applies actions that match risk and business intent. In hybrid environments, sensitive information moves through email, web uploads, collaboration platforms, and endpoints, often through channels that are legitimately allowed, which is why DLP is designed to operate inside normal pathways rather than only at the perimeter. The real skill is deciding what to protect first, where to apply inspection, and how to tune policy so alerts are meaningful and enforcement is predictable. When DLP is deployed with this balance mindset, it reduces leakage risk without driving users toward unmonitored alternatives. Before we continue, a quick note: this audio course is a companion to the CloudNet X books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. DLP detects sensitive patterns in files, text, and transfers by using matching techniques such as pattern recognition for regulated identifiers, document fingerprinting, classification labels, and sometimes contextual rules like destination type and user role. Pattern detection can catch common sensitive elements like account identifiers and personal data, while fingerprinting can recognize specific protected documents even if their format changes. Transfers are important because DLP must observe movement events such as uploads to web destinations, attachments leaving through email, copy to removable media, or synchronization to cloud storage clients. The exam often expects you to recognize that detection is both content and context, because the same piece of data may be acceptable in one flow and unacceptable in another, depending on destination and authorization. Detection also depends on visibility, which can be constrained by encryption and by where inspection is placed, making placement decisions part of effectiveness. When you can describe DLP as pattern and movement detection, you are already speaking in exam-friendly language. DLP actions typically include alerting, quarantining, blocking, or encrypting based on policy, and choosing the right action is where DLP becomes either sustainable or disruptive. Alerting is the least disruptive and is often used when you want awareness and measurement without immediately interrupting workflows. Quarantining holds content for review, which can be appropriate when you need human validation before releasing or escalating, but it also introduces operational load that must be planned. Blocking prevents the transfer, which is effective for high-risk events, but can cause user frustration if applied too broadly or without clear alternatives. Encrypting, or applying protective wrapping, can allow a transfer to proceed while still protecting confidentiality, which can be useful when the business needs the workflow but requires stronger safeguards. The exam tends to reward the idea that actions should be proportional to risk and that enforcement should be phased, because DLP is most successful when it guides behavior and reduces leakage without creating constant disruption. Prioritizing crown jewel data first is essential because DLP can generate large volumes of events, and trying to protect everything at once often overwhelms teams and results in noisy policies that are eventually ignored. Crown jewels are the datasets and documents that would cause the greatest harm if leaked, such as customer records, regulated identifiers, intellectual property, and sensitive internal plans. By focusing on these first, you can build strong detection patterns, validate them against real workflows, and apply enforcement where it matters most. This prioritization also makes exception handling more manageable because you are dealing with the highest impact use cases rather than a broad and fuzzy set of sensitive definitions. The exam often expects you to show this risk-based approach because it demonstrates that you understand limited operational capacity and the need to produce actionable results. When crown jewels are protected effectively, you can expand scope gradually using the same tuned policy methods. False positives are one of the biggest practical challenges because DLP patterns can match benign content, and noisy policies create user friction and operational fatigue. Tuning reduces noise by refining patterns, adding context conditions, and adjusting thresholds, which helps avoid alert floods that make DLP seem unreliable. User friction matters because if users are blocked frequently for legitimate work, they will seek alternate channels, and those channels are often less monitored and less secure, creating the opposite of the intended outcome. The exam expects you to recognize that tuning is not optional because an untuned DLP deployment becomes either a nuisance or a bypassed control. Tuning also improves trust because when users see that DLP actions align with real risk and are applied consistently, they are more likely to comply and to report issues rather than circumventing. When you frame tuning as protecting availability and productivity, you show the balanced mindset that exam scenarios often reward. Endpoint versus network DLP placement is a key design decision because placement determines what you can see and what actions you can enforce, especially in a world where most traffic is encrypted. Endpoint DLP runs on the device, allowing it to observe actions like copying to removable media, printing, screen capture attempts, and local file operations, as well as application-level events like uploads from a browser or client. Network DLP sits at egress points such as proxies or gateways, observing transfers leaving the environment and enforcing policy at choke points, which can be easier to manage centrally. The trade-off is that network DLP may have limited visibility into encrypted content unless transport layer security inspection is used, while endpoint DLP can see content before encryption but requires agent deployment and consistent device management. The exam often tests that you understand these trade-offs because the correct placement depends on whether you are protecting managed endpoints, whether egress can be forced through choke points, and how privacy and inspection policies are governed. When you choose placement intentionally, DLP becomes effective rather than partially blind. A scenario that illustrates practical enforcement is stopping a customer data upload to personal cloud storage, which is a common leakage path and a common exam pattern. A user attempts to upload a file containing customer identifiers to a personal storage account, and the destination is not approved for sensitive data. DLP detects the sensitive pattern in the file and evaluates the context, such as destination category being personal storage and the user not having authorization to transfer regulated data to that channel. A policy action blocks the upload and generates an alert, possibly with user messaging that explains why the action occurred and points to an approved alternative. The key is that the policy is narrow and clear, targeting customer data and personal storage destinations, rather than blocking all uploads or all cloud storage indiscriminately. This scenario demonstrates how DLP reduces leakage by constraining where sensitive data can go, while still allowing business workflows to use approved collaboration platforms. When you design the policy this way, enforcement protects data and also guides users toward compliant behavior. A pitfall is blocking without training, because when users do not understand why actions are blocked and what they should do instead, they often create shadow IT workarounds that bypass DLP entirely. Blocking can feel arbitrary if users do not know what counts as sensitive or which destinations are approved, and confusion turns into frustration and bypass behavior. Training should be practical, focusing on clear examples and on approved alternatives, because users need a path to complete their work without guessing. Reporting channels also matter, because users need a way to request exceptions and to report false positives without resorting to personal accounts and unmonitored tools. The exam often expects you to connect DLP success to people and process, not only to technology, because DLP touches daily workflows and therefore must be adopted rather than endured. When training and alternatives are built into the rollout, blocking becomes a guide rail rather than a roadblock. Another pitfall is ignoring encryption and inspection limits, because DLP effectiveness depends on visibility, and encrypted channels can hide content from network-based inspection. If the organization deploys network DLP but does not route traffic through inspection points, or does not enable transport layer security inspection where policy allows, the DLP engine may only see destinations and metadata, limiting its ability to detect sensitive content in uploads. Endpoint DLP can mitigate this by observing content before encryption, but only if endpoints are managed and the agent is deployed and healthy. The exam expects you to recognize that DLP is not magic and that coverage depends on where data can be observed, which is why placement and inspection policy decisions must be part of the design. Ignoring these limits often leads to overconfidence, where teams believe they are preventing leakage while large channels remain opaque. When you acknowledge and address visibility constraints, your DLP strategy becomes more realistic and defensible. Quick wins include starting in monitor mode and then enforcing on a narrow scope, because this approach builds confidence, reduces false positives, and prevents sudden disruption. Monitor mode allows you to collect data on how often sensitive patterns appear in transfers, which channels are most common, and which policies would generate the most noise. Narrow enforcement can then focus on crown jewel data and the highest risk destinations, such as personal cloud storage or external email, where the leakage risk is high and the business justification for restriction is strong. This phased rollout also supports stakeholder alignment, because you can show evidence of risk and proposed policy impact before blocking workflows. The exam tends to reward this gradual enforcement approach because it demonstrates operational maturity and acknowledges that DLP is a behavior-influencing control that requires tuning. When you phase in enforcement, you reduce the chance that DLP is disabled due to backlash. Operationally, building a feedback loop with business owners is critical, because DLP policies intersect directly with how teams do their work, and business context is needed to tune policies intelligently. Business owners can clarify which workflows are legitimate, which destinations are approved, and what alternatives exist when a transfer is blocked, which helps reduce false positives and reduces user frustration. Feedback also helps identify when a policy is too strict, too loose, or misaligned with real processes, allowing adjustments that keep both security and productivity goals intact. This loop should include regular review of high-volume alerts, common exception requests, and confirmed leakage attempts, because those signals indicate where policy needs refinement. The exam often expects you to show that DLP is governed, not just deployed, because governance is what keeps policies current and trusted. When the feedback loop is active, DLP becomes a shared risk management practice rather than a security-only enforcement tool. A memory anchor that fits DLP is know data, watch movement, tune, enforce gradually, because it captures the life cycle that keeps DLP effective and sustainable. Know data means identify crown jewels and define sensitive patterns and classifications clearly, because vague definitions lead to noisy detection. Watch movement means place DLP where it can observe transfers, whether on endpoints, at gateways, or both, ensuring the policy engine sees the events it must control. Tune means refine patterns and context to reduce false positives and user friction, protecting adoption and availability. Enforce gradually means move from monitoring to selective blocking and other actions in a phased way, focusing on the highest risk channels first. This anchor helps answer exam questions because it guides you toward a practical rollout plan rather than an all-at-once enforcement stance. A prompt-style exercise is choosing a DLP action for 3 different events, because action selection is a common exam pattern that tests proportionality. If an employee attempts to upload customer identifiers to a personal storage site, blocking is often appropriate because the destination is unapproved and the risk is high. If a user emails a document that contains sensitive patterns to an approved partner domain under a contract workflow, encrypting or allowing with alerting might be appropriate depending on policy, because business needs may exist, but controls should still be applied. If DLP detects a potential match in an internal transfer between approved systems, alerting may be sufficient initially, while tuning confirms whether the match is truly sensitive or a false positive. The exam expects you to justify the action based on destination risk, data sensitivity, and workflow legitimacy, rather than applying the same action to every event. Practicing these choices builds the ability to propose policies that protect data without creating unnecessary disruption. Episode 110 concludes with the idea that DLP succeeds when it protects crown jewel data through controlled actions while respecting real workflows through tuning, phased enforcement, and strong communication. DLP detects sensitive patterns in content and transfers, applies actions like alerting, quarantining, blocking, or encrypting, and becomes effective only when placement provides visibility across the channels where data moves. The biggest risks are excessive blocking without training that drives shadow IT, and ignoring encryption and inspection limits that create blind spots, and both are addressed through monitor-first rollout and careful scope selection. The policy tuning rehearsal assignment is to take a narrow DLP policy, narrate how you would run it in monitor mode, analyze false positives with business owners, adjust detection context, and then move to targeted enforcement for the highest risk destinations. When you can narrate that tuning process clearly, you demonstrate exam-ready understanding that DLP is a governance and operations problem as much as it is a technology capability. With that mindset, DLP becomes a practical guardrail that reduces leakage without stopping business. Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.